This is the third trigonometry unit. It's actually our fifth unit of this course if you're doing advanced functions with me, but it's the third trigonometry unit. However, it is the first trigonometry unit where I will expect you to be able to consistently hit your trig buttons, which are sine, cos, and tan. Now, most of you will not have these three. I actually don't know why I do. It's kind of handy, but I'll be ignoring them, even though, as you might see down here in my note, I've got cosecant, secant, and cotangent, the ratios, but I'm going to ignore these because most calculators don't have them at all. What is important is that your calculator is consistently on degrees. So whether you have a reset button on the back of the calculator or on the front that you just tap gently, which takes it back to degrees, it may take a DRG button. It may also mean going into your mode setting. So somehow you have to make sure your calculator's on degrees, and I can help you with that if it's not, or if for some crazy reason it flips. The other option for this calculator is Radians, which you know something about, and you can use it, only I will be using degrees. I think this calculator, oh, there it is, gradients. Not quite sure what that does. I think it's another angle measurement. So degrees for temperature, you can have Fahrenheit, Celsius, and kelvins. If you're in science, I don't know if gradients is another type of angle measurement for size of an angle, but I have never used it. I'm going to set this calculator on degrees, and we're going to go forward with this stuff. You need to take a look at a couple of things for each question. Now, for the 8 questions we're doing on this page, I need all of our answers to be in degrees, and I need all of our answers to be between 0 and 90 degrees. If it isn't in degrees, or if it's outside of 0 to 90, then you're not allowed to write it down as part of your therefore statement. So I'm going to show you how to use your calculator. I may kind of quit after doing this kind of stuff and then make a second note or lesson. It would be a continuation. We'll see how my timing goes. I've already talked for almost 3 minutes and we haven't even started the note. So with this question, what I want you to be able to do is I want you to do the sine inverse of this. So basically, I've given you the O over H decimal version, and you're trying to figure out how big the angle is for that triangle. So this is Jeopardy. So the way you do that, and it depends on your calculator, but you put in the 0.875, making sure that your calculator's on degrees, and then you hit second function to access this part of it, and you do sine inverse. And that takes us, let's go to 1 decimal place, 61.0 degrees. So I can say that x is 61.0 degrees, and that's my therefore statement because it is between 0 and 90 degrees. Now, if your calculator is backwards from this, so if you have a display model calculator, you will have to hit second function or shift or inverse sine and then put in the 0.875. So it depends on your calculator, and you're going to have to figure out which one yours is. But that's it to this question. To be honest, 0 to 90 is the best space that you can use. So you're supposed to be happy with this. So second question is x equals, so same deal, only this time instead of second function sine or sine inverse, it'll be cos inverse, and you're applying it to this decimal, which represents the adjacent over hypotenuse for a triangle, and we're trying to figure out the angle for that. So again, only different numbers. For me, I punch in the decimal first, and then I access the trig, which for me means a menu, you likely not. Second function, so that you get the cos with the -1, which is cos inverse. Hit that button, and to one decimal place, 88.7 degrees. And because 88.7 degrees is between 0 and 90 degrees, this is our therefore statement. And you shouldn't really have a whole lot of problems with these questions, because this ratio I've given you is positive. And if you think about it, the cast rule says all ratios are positive in 0 to 90. So it doesn't really create any issues. Let's go on and do this one. I do want you to still access your trig resource sheet if you've made one, or your list of trig identities, but you certainly don't use it for this question because you actually have a tan button. So the steps are that you're going to have to take the tan inverse of 4.531 using your calculator, and it's impossible to do a lot of questions, not all questions, impossible to do a lot of the questions without your calculator. So 4.531, second function, tan, is 77.6 degrees. 77.6 degrees is between 0 degrees and 90 degrees. So we're good to go. Now the question is, what are you going to do with these three? I'm going to take these two. Hopefully I've made them movable. Oh, I did. A little below because I'm not sure about my spacing. So this question is cosecant, and unless you're me, special me, you don't actually have a cosecant button. And I don't know why cosecant is second and secant is first. That should be rearranged, but I'm not going to use those because hardly any of you have them, like I said. So we have to find a way around it, and the way around it is by using the identities. So hopefully you remember, or have written down somewhere, that cosecant x is the same thing as the reciprocal identity 1 over sine x. That's this replaced. This does not get replaced, it just gets recopied. But that doesn't let us use our button directly. So I am going to put a 1 down underneath here, and then I'm going to cross multiply. So that's 3.412 times sine x equals, cross in the other direction, 1 times 1 is 1, divide both sides by 3.412, so we end up having sine x is equal to 1 over 3.412. And although we aren't done this question, can you see a quick way to approach this next question? Because I can. This is the reciprocal of cosecant, so I can take secant and do the reciprocal of it, which is cos x. And then this is the reciprocal of this. So we just need to find the reciprocal of 9.374, which is 1 over 9.374. So you can skip a whole lot of math steps if you know what the word reciprocal means, which is upside down. So we found the upside down of secant, and you put the upside down of the decimal. Now let's finish off this question. See, I knew I wasn't sure about this spacing. We have to do sine inverse of 1 divided by 3.412. So that means I have to do the 1 divided by 3.412. I need to find that decimal, and then I need to do the sine inverse. So 17.0 degrees, 17.0 degrees is between 0 and 90 degrees. So we're done. If you're doing it the other way, as in if your calculator is display model, you can literally punch it in like this: sine inverse bracket 1 divided by 3.412 bracket equals, and you will spit out the same answer as long as your calculator is on degrees. So I'm going to do this one, which I can actually see, so it's not really all that, I don't have to remember this very much. So x is equal to cos inverse of 1 divided by 9.374. And I'm going to assume that I'm going to get a real answer, so I'm going to put the therefore down, but let's check if I'm right. Remember, I need a degree answer between 0 and 90 degrees. So for me, 1 divided by 9.374 equals that decimal. And then trig, so you can just hit your second function, shift or inverse, and then the right trig word, which is cos in this case, originally secant, now cos, and I get 83.9 degrees. Color coding is off. 83.9 degrees rounded to 1 decimal place. So with this one, you do not have to use cotangent is cos x over sine x, the quotient identity. Instead, you have a tan button. I don't know why it keeps flipping. You have a tan button, so you're going to flip cotangent to its reciprocal, and you're going to flip 5.391 to its reciprocal, and then do tan inverse of something. In this case, this fraction. I would not type this in and find out what it is and then write it down. Let your calculator do the work so your accuracy is maintained. So 1 divided by 5.391 equals, don't write that down. Don't write part of it down. Just let your calculator do that work, and then trig, second function tan, and I do have an answer between 0 degrees and 90 degrees, 10.5. Okay, last two truly calculator questions. So let's see what happens. I'm just going to move this over slightly because I can, and then I'll be able to see the work. Let's see what happens when I do 1.973, making sure that it's negative, trig, second function, sine. Oh my gosh, it's an error. There is actually no answer to this question. No answer between 0 and 90. No answer at all, actually. So, not what I intended to do again. So, with this question, I personally would say no solution. Let's check this one. So the step is x equals cos inverse of 2.042. So remember, my calculator might be backwards to yours. Oh my gosh, it's another error. These things should not surprise you. And the reason they shouldn't surprise you is if you think about the graph and all this work, every single part of trigonometry goes back to the graphs. They also go back to the triangles. But if you think about the graph of y equals sine x, the graph of y equals sine x did this. More importantly, the graph of y equals sine x had only values between 1, and negative 1. So when I give you a value of negative 1.793 and ask you where it runs into the graph, you can't find a spot. As opposed to this question, which says, can you please run into the graph at just under 1? So in this case, it is, and although it's going to bump into a lot of places, we're concerned about this one because that one is between 0 and 90, and that one is 61.0 degrees. So it all goes back to the picture. So does that explain to you why H has no solution? Because it should. And it should because if you think about the cosine curve without any transformations whatsoever, it is also trapped between 1 and negative 1. So when I ask you about (2.042), it doesn't bump into the curve, so you get no solution. As opposed to this, where if I ask you to draw a dashed line through approximately 0.023, you can see that you get really, really close to the 90-degree mark. So this is what you're doing, only you're doing it with button pushes rather than actually drawing the picture. So the next thing we want to do is remind you that you have a unit circle and remind you that the unit circle measurements repeat themselves all over the place. So you get a lot of 1/2, you get a lot of 1s, you get a lot of 0s, both positive and negative numbers except for that 0. You get a lot of √3/2s, both positive and negative. You get a lot of √2/2s, both positive and negative. So you get super repetitive values here, and that's why I can sometimes ask you for questions asking you to solve trig equations using unit circle values. And it's way easier to pluck answers off of this thing than it is to push buttons on your calculator, I think, personally. So here are 4 more questions, just to show you 4. And I'm asking you to determine theta, which is the same thing as determining x, only I made it a theta. We're looking for degrees, and you know you're looking for degrees because it says determine theta, so find out all the thetas, and we need all the thetas between 0 degrees and 360 degrees. So that means we're expecting answers for theta that are in degrees. So I'm giving you the ends of the sticks, and you're trying to give me the degrees. The problem is I changed this on you. And this says 2 things. 1, it says if you recognize the number off the unit circle, you have to use the entire unit circle. Or if you don't recognize the number off the unit circle, you have to use the cast rule. So let's start the questions. So here's a question, and I don't recognize 1/√2 or negative 1/√2 off the unit circle. Or do I? And this is where all the facts that I've given you so far are pretty important. I told you at one point in the last unit that 1/√2 and √2/2 are the same things. That's negative, so this is negative. So basically, we're going to look at the entire unit circle, because this is a unit circle number. We're going to look at the entire unit circle and look for places where the cos value, the first one, is negative √2/2. So, start the search. So the first value is cos, not negative. There's 1. There's 1. That means our two answers are this degree and this degree. So we get to write down theta equals 135 degrees or 225 degrees. You don't get to write down the cos anymore, and the reason you don't get to write down the cos anymore is you looked that position up. So you write down the 2 that you find, and you're done. Now there's something to be said for these answers, and it's because if I dig out the cast rule, and I think about what these letters mean, and we went over it in one of the last lessons from the last unit, this means all are positive. This is a negative ratio, so not there. This means sine is positive, which also means that cos is negative, so I can search there. This means tan is positive, which means cos is negative, so I can search there. And this means cos is positive, so I don't search there. And it is not a coincidence that we found those answers where we were supposed to, according to the cast rule, because it all fits together. So let's try this one. Only we don't have a cosecant. So make your switch. Cosecant is the upside down of sine, and 1 over 2 is the upside down of 2. So now you can do one of two things. You can just go to the unit circle. Hopefully you recognize that that's a unit circle measurement. You can go to the unit circle and you can list off your thetas, or you can narrow it down for yourself. So I'm going to narrow it down first. We are looking for places where sine is positive, because originally cosecant was positive. Sine is positive in this section because that says sine positive, and sine is positive in this section because this is all are positive. So I should only find answers in the upper 2 quadrants and not the lower. Let's see where I find sine is a half. So sine is the second one. The second one is a half here, which means this is an answer. And sine is a half. Nope, that's a negative a half. Nope, that's a negative a half. Sine is a half here, so that's an answer, and it's just like I said, and that is it's in the upper 2. You have to make sure that your answers are in the space that I asked you about, so 30 degrees and 150 degrees, before I forget. So 30 degrees and 150 degrees, which are trapped between 0 and 360 degrees, so I'm all good. Next question is pretty darn similar. This next question is finding still a half, but this time it's negative. So the thing is, if sine was positive in these two, then it makes sense to me that it's negative in the other two. So I should be looking downstairs for places where you can find sine theta is equal to negative a half. Let's see if that works. So here we go. Those are sine is the second one, being positive 1/2. There they are as negative 1/2. And it is downstairs. So 210 and 330. And it's not good enough to write 210 and 330. you have to write 210 degrees and 330 degrees. You have to specify that these are radian measures, and then don't forget your last little double check. Is it in the space I asked for? Yes, we're good. Last question is a trick question, and I hope you can see that tan theta is equal to -1 is a unit circle measurement. And the reason I say it's a unit circle measurement is because of this. And I'm going to do it in red because it's not one of the obvious ones. So sine over cos is the same thing as tan. So tan theta, sine theta over cos theta, and it equals -1. Which means that the value you get for sine and the value you get for cos would have to be the same values but they'd have to have opposite signs. So they wouldn't cancel out completely and become 1. They cancel out completely and become -1 because there's a negative sign carrying around. So we have to find all the places on the unit circle where you have the same values but opposite signs. So let's see if I can find those places. Same values, same sign, not good enough. Same values, opposite signs. Same values, same signs, not good enough. Same values, opposite signs, that's good. So 135 degrees and 315 degrees. And this also is in the space I asked you to focus on. And it is also in keeping with the cosine, or sorry, the cast rule. Because we should be able to figure out where tan is positive. So tan is positive here, because that's what the T stands for. And tan is positive here because that's what the A stands for. So when we're looking for tan is a negative value, you're going to look in the other two spots, and if I take a look where the 135 and the 315 is, they're in the other two spots. So this is not a surprise whatsoever. I am going to take a little break because my hand is cramping, and I'm going to come back and we're going to look at as many of these questions as possible. I'm going to show you long ways of taking care of this, even though maybe some of these questions have shorter ways. Okay? It's because I know what's coming with the next lesson. So give me a break, and I will be back. Bit longer break than I really wanted. Had some people to talk to. So one of the things that's staying the same with these questions, these 4 questions we're doing now, is the range that I want your answers in. Technically that's the domain because it's X, but it's a range of values, so don't get nitpicky on my language. The space of values we want, space of values, is between or equal to, and this has been the case all along, between or equal to 0 and 360 degrees. So we need our answers in degrees rather than radians, and we need to make sure that they're between 0 and 360. So I'm going to do something that might be a little unnecessary for some of you, but I want you to at least see it once. I won't do it for B, and I'll show you the alternative. But this is a linear equation, and the reason I say it's a linear equation is because we've only got a degree of 1 here. Now, if the trig really throws you off, then what you can do, this is my suggestion, you take all of the cos x, because remember they're attached, and you turn it into a letter. So I'm going to turn it into the letter M for math. Way better than T for trig, because T's look like plus signs for some of you. That should be something that you solve fairly easily. So take the 1 to the other side, change its operation, divide, and get yourself an answer for m. And then realize that, hold on just one sec, this didn't start as an m, this started as a cos x. Don't lose the x. Cos x is equal to 1/3. And now your job is to find the x. So you have to look at the number that is sitting on the right side of the equal sign. You have to figure out if that number is like the last page of numbers where you could just easily select answers off of the unit circle, or is it more like the first page where we had to select numbers using our calculator. And there's a little bit more math if you recognize that it's actually this case. And the reason is because in the first case, I asked you to deal with 0 to 90 degrees. And in this case, I'm asking you to deal with 0 to 360 degrees. So that makes it way worse, air quotes. So I'm going to take this and I'm going to do the cast rule. And there's really no choice about whether or not you do the cast rule. It's going to be really hard to see if you don't do it. So I'm going to doodle here. And I'm going to remind you of some things, and hopefully there's enough examples on this page that you'll be able to pick up the idea of this after 4 examples. So, with the cast rule, where I'm going to write C-A-S-T, I have cos has a positive answer. And when cos is a positive answer, that automatically puts it in here because this means cos is positive. And I get to put it in here because this means all are positive. So that means our answer lies in here, quadrant 1, and in here, quadrant 4. But more specifically, it's in this spot, and it's in this spot. And the reason for that is because it has to stay in the bow tie. So that's half the bow tie sitting right there. So you got the 2 spots right there. So we're going to have to figure this out in a second. When we go to do the math, you're not finding x equals anymore. You're finding RAA. So this takes us back to that first lesson way long ago with Trig. And we're going to do this. So instead of it being a decimal, it's a fraction. And we're going to find out the related acute angle. Ignore this for a sec, I'll move it. So I have to do 1 divided by 3, get that answer, and then do the second function, cos, and get 70.5 degrees. So the steps I did, and I may have to take these 2 questions to another page, but the steps I did to find my RAA was figured out this, then did cos inverse. Remember, you could do this backwards depending on your calculator, and the answer we got was 70.5. So that's 70.5 degrees. That means these tiny little x's up here are 70.5. Hopefully you can figure out the rotation. So hopefully you can figure out that from 0 degrees up to that line is 70.5 degrees. And from 0 degrees around to this line is 360 if I had made it all the way back to this, but I didn't. I fell short by 70.5 degrees, so that ends up being 360 minus 70.5 equals 289.5. So my 2 answers for the x are 70.5 from that first rotation, 70.5 degrees, and also an answer of 289.5 degrees. Both of those are between 0 and 360, so we're good to go. I'm going to do a second question before I draw you a little doodle, and then we'll go on and do those last 2. So with this one, Some of you may wish to avoid this. Some of you may not need it. You may not need it now, you might need it later. So what I mean by that is some of you can take the 8 to the other side of the equal sign, knowing that to isolate tan x like we isolated cos x, it means doing that first of all. And then divide by 5, and we get tan x is equal to negative 8 over 5. Then we can draw our little cast rule. And hopefully you can figure out that tan positive would be here in the tan positive section, and the A, the all positive section, but we have tan is a negative answer, so I'm going to put my sticks, my terminal arms right in there. The little x's have to go inside the bow ties. So now I do my calculator work because I don't recognize this number off the unit circle. So my RAA is equal to, and there's a bit of a trick here, tan inverse, and no, I did not forget the negative. You don't use the negative in the calculator. So I'm going to punch that in. I'll show you why in a sec. 8 divided by 5 equals trig second function tan, and I get 57.99, so that's 58.0 degrees. And that is not the answer, that is the RAA. So this, from here all the way around to the line would be 180, but I didn't make it to 180. I fell short by 58.0. So this is 180 minus 58.0. I'll figure that out in a second. And this one is the same as this one, so 360 minus 58.0. So my X answers, my final answers, are 180 minus 58.0 is 122.0 degrees, and also 302.0 degrees. Both of those answers are between 0 and 360 degrees, so I'm good to go. Now, why don't you put the negative in the calculator? You don't put the negative in the calculator because if I do negative 8 divided by 5 equals, and then I do the second function tan, wait for it, it gives you a pretty similar answer, but a negative. And sometimes it's way off, and sometimes it's just subtly off, like this one. This is because tan is actually decent with this. This isn't an acute angle. Acute angles are between 0 and 90 degrees. You're expecting answers between 0 and 90 degrees, not negative. So you can't accept this answer, and some of them are harder to fix than others. Some of them you don't just chop off the negative and use the positive value. So that you don't overthink it, you just don't put the negative in. That means your answer will lie in quadrant 1, which is acute anyhow. The picture I want to draw for you is, and I may add to it in the future, I'm going to take these guys sideways. The picture I want to draw for you is this. Here's your cast rule, but incomplete. You'll have a terminal arm in each quadrant, 2 out of 4 of them. If you're in this quadrant, your RAA is your answer. If you're in this quadrant, the math you will always do is 180 minus your RAA. And we did that here. If you are in quadrant 4, it's 360 minus your RAA. We did that here and here. And if you're in the quadrant we didn't do yet, that's 180 rotating from 0 degrees around to this line, and then a little bit extra, and that little bit extra causes you to add on your RAA. So now let's do 2 more questions. How do I access them? These guys. The secondary trig ratios, which shouldn't actually cause a problem. And you have the option, even though I'm not going to use the m's, you have the option of doing this if you choose. Maybe I'll do this for the second one and not do it for the first. Your choice, depends on how well you see things. Let's go for black. So 7 cosecant x equals positive 9 on the other side. Divide by 7. Divide by 7. We have cosecant x is equal to 9 over 7, which is great, except I don't have a cosecant button, so I have to reciprocate it, turn it upside down. And if I turn one side upside down, I turn the other side upside down. I do not recognize this as a unit circle measurement, so I have to dig out the cast rule. And sine is allowed to be positive in the all positive section and the S, the sine positive section. So when I figure out my RAAs, they fit in there. So RAA is equal to, it's hard to screw this one up because you don't actually have to remove a negative. It's not there. So that's kind of nice. 7 divided by 9 equals trig sine. Let's try that again. 7 divided by 9 equals trig second function sine, and I get 51.1 degrees. So, final answers. This is just 51.1. Ugh, time to go to bed. 51.1 degrees. That's because your RAA is your answer. This quadrant is 180 minus 51.1. I can check here for help in quadrant 2. There it is. And I can't do that in my head tonight, so 180 minus 51.1 degrees equals 128.9. And just to refresh your memory, both those answers are between 0 and 360 degrees, so I'm good. So this one might be a little more complicated, so I'm going to do the little m thing. So 3m takes the place of cotangent x in case you really just don't want to look at that. Plus 2 equals 4. So 3m is equal to 4 minus the 2. 3m is equal to 2 divided by 3 divided by 3. So m equals 2 over 3. But that was actually cotangent x is equal to 2 over 3, which means tan x is equal to 3 over 2. So reciprocal of cotangent x, reciprocal of 2 over 3. Turn this upside down, turn that upside down. So cast rule. Figure out where tan is allowed to be positive. So tan is allowed to be positive in the all quadrant area, and it's allowed to be positive where the T is, because that means tan positive, and my little X's go in the bow tie. So time for the RAA, which is tan inverse of the 3 over 2. Three divided by 2 equals trig, second function, tan, 56.3 degrees. And if you want to scribble that in your picture, you totally can. Or you can say, okay, that's 56.3 degrees, and this is 180 plus an extra 56.3 degrees. And this is kind of scribble, so if you leave off the degrees, I'm not going to lose my mind in any way. Somebody might. (180 plus 56.3 degrees is 236.3. (236.3 degrees. And those are your answers. Now I'm going to see what's left. I'm probably going to talk through these, even though I'm at, yikes, 47 minutes. And that's because I changed the space on you. So let's see what happens here, and then we'll see what, oh, this one's first. Oops. So actually, because I've got some space, I'm going to put this back here. And we're going to take a look at these two questions, which were question 3, C, and D. And we're going to answer this space. For the record, that does not mean that you have to redo the entire question. That would super suck. All that says is that you're taking your answers from your 0 to 360 area, and you're turning it into radians, because 0 to 2 pi is the same as 0 to 360, only it's using different units. So your job is to take question C up above, where we got an answer of 51.1 degrees, and another answer of 128.9 degrees, which are just fine for degrees, but aren't fine for radians. All we have to do is convert those. So if somebody asks you for radians, you just have one more thing to do, and that is to use the conversion factor. So again, I reminded you that you have to go all the way back to that trig. The thing is, because these are awful numbers, there is no need to reduce any fractions or anything like that. Instead, you just straight up use your calculator. As in, for the top one, I do 51.1 times pi button, or 3.14, divided by 180, and I get 0.89 radians. And you have to be super specific that you have converted. Then clear it off. 128.9 times pi, or 3.14, divided by 180 equals, and we get 2, oops, I should have paid more attention, 0.25. Again, be specific, radians. So when I give you the same space but different units, it's okay. It's just one extra little thing to do, and it's not complicated math. It is kind of annoying, I'll admit it. So with D, one of our x's was 56.3 degrees, and a second one of our x's was 236.3 degrees. Now I'm going to show my work. If you want to just plunk this out on your calculator, that's fine. And having said that, these kinds of questions you never do at schools that don't let you use your calculator. What kind of questions do you do? These ones that you can just pluck off the unit circle. But the ones we did here did not require the unit circle because there were some really crazy numbers. So now you just use your calculator. So you're actually literally in one school or the other. So therefore x equals, and I'm going to come out with my two answers. I know I have to move my calculator back. So it doesn't mean changing your calculator to radians. You can if you choose, and you can ask me how to do that if you want. If you do want to know, make sure that you have this picture handy with you when you ask me the question, because this is the picture I will slightly adjust in case that gives anybody any helpful hints. So first one, 56.3 times pi button or 180 divided by 180, pi button or 3.14, and that's 0.98 to 2 decimal places. So my rule is usually 1 decimal place for degrees, 2 decimal places for radians. And I'm writing them on the up and down instead of the side to side so I can literally show you my conversion. And the last one, finally, 236.3 times pi button or 3.14 divided by 180 equals 4.12. Be specific. Radians. All right. I'm going to do it. Truly the last question. So you can go all M with this if you want, or not. Up to you. And these first steps have nothing to do with this, so I've ignored it for the time being. And I do not recognize that as a unit circle measurement, which means I need the cast rule. And this one is sine being negative. So sine is positive here in all positive and here in sine positive. So I'm going to put my sticks in the other two places with the little x's for the RAAs. Do you remember what to do here? I mean, there's lots of tiny little subtle steps that might annoy you, like don't put a negative into your calculator. Don't do that for solving trig equations. So 1 divided by 5 equals a decently nice decimal. Second function, sine 11.5 degrees. How do I know it's degrees? My calculator's on degrees. Okay, so now the problem. You've got all your information, and you have to look at what I want. And what I want are only numbers from negative 90 degrees up to positive 90 degrees, because pi over 2's are 90 degrees, and we can check our unit circle to prove it to you. So I need to make sure that I go in this direction 90 degrees and in this direction 90 degrees. So that means even though that's a perfectly acceptable answer for some questions, it's not a perfectly acceptable answer for this question because it's out of the space. This one's okay. And that one is a couple of different answers. I mean, really, we could do 360 minus the RAA, which is 11.5 degrees. And you could get it, 11.5 degrees. And you could get an answer. But I kind of hope that you can look at this picture and you can say, therefore, x is actually equal to negative 11.5 degrees, which actually puts you between the negative 90 and the positive 90. Whatever this answer is, it's going to be 300 and some. That's not going to work. That's not going to apply. So you have to make sure that your answers actually apply properly. But we need one last therefore statement, even though this is the only angle that applies. And the reason is because we need to make sure that we have radian answers. So my final therefore statement, so nice, big, bold, therefore, x equals, I've got my 11.5 there. Let's make sure I don't make any silly mistakes. So 11.5 negative times pi divided by 180, 2 decimal places, negative, doesn't surprise me, 0.20. And that again is radians. So notice that my degree answers have the degree sign, my radian answers have the radian sign. So that takes you through step 1 type questions. You will get very few of these guys and a whole lot of questions that are either between 0 to 360 or, the radian equivalent of 0 to 360. I don't know if this is it, but you can check the Google site to figure out if it is, and I believe that this is an ISU for you, so good luck with that. You will need to make sure that you know this to move on to the next stuff. So that is that. Talk to you soon. Under an hour. I made it.